Welcome to my Texas workshop. I'm Randy Lammers.
I'm Aaron Keevan.
This is Würth Knowing. You need high corrosion resistance, maybe dealing with environmental concerns. Zinc Flake coatings might be the answer for you on fastener finishes. As you can see right here, they're very, very nice looking, and we're really excited, Aaron, about what's going on in the technology today.
Yeah, a lot of development's been happening over the last 20 years in those.
Absolutely.
Yeah.
So good stuff. So we're seeing corrosion resistance, and we talked about hours of corrosion resistance in a accelerated test.
Yeah.
So the same thing, accelerated testing, hours. We're talking about 250 hours minimum, upwards of over 1,000 hours.
And we start typically in sizes starting at 1/4 inch, and that's a M6 in metric.
Right. We can do smaller sizes, but we have to thin it out. And when you thin it out, you're going to lose some of the corrosion resistance. But this is a relatively thick coating, so it's a little bit thicker than electroplating, so we typically try to stay in that M6 1/4 and above.
Exactly right. One of the other benefits is we don't have to worry about hydrogen embrittlement, so that's awesome.
Thank goodness for that.
They're chromium 6 free, hexavalent free, which
Correct.
is awesome.
Yep, environmentally friendly.
We have lower cure temperatures when they actually have to get these things secure on the fastener.
About 400 degrees for most of them.
Yep, true. Also friction modifiers, that's awesome for torque control, torque detention control.
Yes.
Yeah.
So a lot of really good things going on with the fastener finishes on zinc flake coating. ASTM has covered this now with a brand new specification.
Yeah, 3393.
ASTM F3393. So what they did in that spec just came out back in August. And by the way, the ISO specification for metric is ISO 10683. But in the ASTM F3393, they gave you different codes. So we have a code for what corrosion resistant you want. We have a code for what color you want. You can see right here, these finishes come in different colors. And they have a code for the coefficient of friction.
Yeah, you got a plus or minus 0.04, which is awesome to help control that torque a little bit better when you're
torque
putting
to
in your
tension relationship, a much smaller scatter than we're seeing with other finishes. So we're very excited. Great job on that new specification.
And one of the, actually I think the biggest benefit is it's actually affordable. So it's not just, it's something we can look at as a replacement to zinc.
Yeah,
plating.
so in terms of affordability, so the thin coatings down at the 240 hour range, those coatings are price competitive in large bulk with electroplating in the high range of electroplating corrosion resistance. So we're seeing a lot of customers making a switch here.
Right. So it starts about the thickness, about 12 microns is about right?
Yeah, so the anywhere about 8 microns for the real thin coatings, upwards to about 12 to 14 microns for the thicker coatings and the higher corrosion resistance.
Sure. And then prep on something like this, they do maybe a shot blast or a phosphate in order to help for the surface preparation?
Yes, so thank you for that. So you can either shot blast, we prefer. We've had some issues with some of the shot finding its way into the finished material. So you can either shot blast though, or you can do a phosphate. Now the phosphate is a really good finish in order to give you the adhesion that you're looking for. So they actually refer to this as a paint. Now, in addition to a first coat and very, very nice matte gray is what we're looking at on a zinc flake coating. So when this is laid down, it goes through a cure oven, again, about 400 degrees, maybe upwards to 600 degrees on some of the formulas. And it lays down like, it's a zinc flake, it lays down like shingles on a house. And then in the cure process, it cross-links that to give a very nice, pretty flat surface. So very, very effective, good coverage on this surface.
Kind of looks like a cornflake once you look at it in a picture.
It does look like a cornflake. I never thought about that way, but it really does.
So you have some different formulas that we would use in these types of coatings, right?
Yeah, so you have the base coat, and then you have the organic or inorganic top coats. And by the way, that's where your colors go, that's where your friction modifiers are in the top coats. Upwards of over 1,000 hours salt spray resistance, so high salt spray resistance when you do multiple coats.
The thin coating systems, we briefly touched on that. I think we're seeing some pretty good results out of that stuff. And you've got, again, touching back to ASTM F3393, you get that color code. You also have a coefficient of friction modifier.
You do.
Yeah.
Absolutely. So what we're seeing on the thin coat systems is taking the place of electroplating. So we have customers that have been doing the electroplating in the hexavalent chromate and the high corrosion resistance there, moving over to the thin dip spin coatings at 240 hours, cost competitive in large bulk volume, and being very happy with that.
Right. Another thing I've seen too is actually having a zinc flake placed over an electroplating.
Yes, so that's kind of exciting. We have a couple of systems that are out there on the market where they electroplate, put the trivalent chromate on top of that, and then a very 1 to 2 micron, very special dip spin formula on top of that. So it works very well in the very small parts, and we're seeing 500 to 1,000 hour salt spray resistance. Incredible. Great for exterior use.
Yeah. What about bimetallic protection?
Bimetallic protection, yes. So the zinc flake coating is it's about a 10% titanium binder, and then it also has aluminum. So very important going into aluminum, where we're kind of worried about galvanic corrosion. So you can do the zinc flake coatings instead of stainless steel, and it reduces the concern about bimetallic corrosion.
So I guess maybe the last thing we need to talk about is how is this actually applied? We call it dip spin. So what are some of the other aspects of application? How they
so
would be
you'll
applied?
hear that a lot. So it's a zinc flake coating, but a lot of us will refer to it as dip spin coating. So dip and spin is certainly really popular in fasteners because most can be done that way. But in addition to that, maybe you have large parts or long length threaded rod. You can do a dip and drain. You can do a air spray gun, just like you're spray painting, or you can do a dip and then spin the entire rack. So those are the mechanisms. Dip spin, by far though, is what we see on most fasteners. Now, speaking of that, I've got a little demo, and it's going to be really fun. Are you ready for this?
Yeah, sure thing, Randy.
Let's do it. Okay, Aaron, are you ready to dip and spin?
Sure thing, Randy.
Okay, here we go.
Oh, really, Randy? A salad spinner?
Sure, dip and spin. Are you ready for this? This gonna be fun. All right, so we're gonna put our fasteners in this basket here. Oh, you think we need to put glasses on?
I'm definitely putting mine on, Randy.
All right, let's put our glasses on. All right, safety first, right? Okay, so we have our fasteners in our basket. We're gonna do just a small batch real quick. Okay, ready? So we're gonna dip it into our paint.
Sure.
Yeah, let me get my basket over there. So we're gonna dip it in our paint, get it in there, get good coverage in there. All right, some of the paint out of there. Then, this is how it works. You put it in the spinning, and get that on there, and you ready? What are you moving away for? Okay, and we spin it. Now, in reality, it tilts, and it spins, and it tilts, and it spins. You like that?
Yeah.
Okay,
it's pretty
so
true of
what's
the
happening
process.
is that centrifugal force is evenly dispersing the paint across all of the surface, evenly dispersing across all of the surface of the fasteners.
Sure.
Kind of cool, huh? We'll hit our stop button before we...
That's a good idea.
You like that?
It's the
You like
first
that
good one you
idea?
had today, Randy.
Okay, so now here we have our dips and spin fasteners. So
Looks great.
those would now, they look very good, evenly dispersed all throughout the threads, and it's a very even coating. That now goes into a cure oven. Do we need to take them in the house and put them in the oven?
I don't think that's a good idea.
I don't think I get by with that
Yeah.
one. No, so that's the process right there. Dip and spin, goes through the cure oven. Now, if we wanted to build up thickness, we'd take them back through that same process again, and the other top coats go through that same process
Yeah, those
again.
modifiers we talked about earlier.
There you go.
Yep.
Dip, spin, coatings, zinc flake coating. Fun stuff. So in conclusion, great corrosion resistance and environmentally sound. But Aaron, there are some challenges with zinc flake coatings.
Yeah, you've got to worry about recess fill. That's one that I can think of. That's where it gets inside the drive types of your screws.
Specifically on 6-lobe drives, Phillips drives, small diameter, in that dip and spin, if you don't get that spinning just right and get it tilted, you can come up with upwards of 3% of those recesses filled in.
Sure.
Big concern there. The other thing is nesting of flat washers.
Yeah.
Same situation. If you can think of this, you got a stack of flat washers end up stacked, you dip it, you spin it, and if they end up staying stacked in the cure oven, then they will actually cure together. So the applicators will do things like drop them on the conveyor belt to try to break them apart, but it is a concern on flat washers. Conical washers are particular concern because the conical shape of the washer, they nest together and it's very difficult to get those apart. So we typically will suggest for those type of items, other means of fastener finishes.
Yeah, they sure are. Another one I could think of is nylon insert lock nuts. So in electroplating, you can add ductile enough you can actually bend over on a nylon insert lock nut, but with these, the zinc flake, you can't do that.
Yep, the zinc flake coating, once cured, is somewhat stiff and brittle. So if you have bent parts, you want to make sure those parts are bent prior to applying zinc flake coatings.
So we talked a little bit about those challenges, but the advantages, I think, outweigh a lot of this.
Oh, yes.
We've got the high corrosion resistance, 240 hours plus, environmentally sound.
Absolutely.
Global availability, that's a big one.
Yes, these applicators are available globally, so you can reference the ASTM and the ISO specifications and get product done globally. I will say this, there is some quality difference among applicators. We keep a very close eye on that to make sure that the applicators have the correct equipment.
Sure, sure. Licensed applicators for sure.
Licensed
That's where we wanna
applicators.
go.
So Aaron, with the finishes over 1,000-hour salt spray tests, a lot of customers are replacing stainless steel with zinc flake coatings. So that's a high corrosion resistance. And when you do that with steel parts in the coating, it's about a 30% cost savings.
Wow.
Pretty significant.
Sure is.
Zinc flake coatings, high corrosion resistance, competitive price. We're very excited about it in the fastener industry, and that's worth knowing.
Click like, subscribe, and we want to hear from you. Leave us a comment.